Hey y'all, welcome back to another video. Today, before we actually get into the questions, I want to explain a quick mathematical formula with gas. It's more like a definition of a term here, because most of these are going to be mathematical formulas today. So most of them are also going to build on this term. So take a to the power of n, for example. A to the power of n would equal, by definition, a times a dot 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 a, and there are n of them. So keeping that in mind, let's get into the first question. Prove that a to the power of m times a to the power of n equals a to the power of m plus n. So as you know, a to the power of m works the same way as a to the power of n, except there are m of them. So keeping that in mind, our equation in this case will be a times dot 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 a, there are m of them, times a times a times a dot dot dot, there are n of them. So in this case, there are m a's plus n a's. So together, that would be a m plus n. So a to the power of m times a to the power of n equals a to the power of m plus n. Moving on to question number 2, this has a pretty similar basis here. A to the power of n times b to the power of n equals a times b in parentheses to the power of n. So this follows sort of the same formula, because you know that a to the power of n, let's write this down, a times a dot dot dot, a of them, there's n, times b times dot dot dot, n of b's. So you can see in this case we can use the associative property, since it's all multiplication, to rearrange its places. And since they're all power of n, it would be ab times dot 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 ab. There are n of them, so it would equal ab in parentheses to the power of n. Moving on to question number 3. A to the power of m divided by a to the power of n equals a to the power of m subtract n. So we need to prove that equation. So writing this down real quick. Equals, and since fractions are basically the top divided by the bottom, we can write it into fraction to make it easier. So then that would equal, as I said in the definition above, there are m of them, and on the bottom there are n of them. So if we even these out, m a's divided by n a's, and we even them out to find out how many a's are left, it would be a to the power of m subtract n. Moving on to question number 4. A to the power of n divided by b to the power of n equals a divided by b to the power of n in parentheses. So if we were to solve this, this is quite similar to the one above, actually. So let's write this down real quick again. It would equal a-n, sorry, that doesn't look very similar, a-n over b-n. So if we put it into expansion mode again, dot dot dot, a n of them over b dot dot, also n of them, then it could be n ab's if we put them into pairs. So if we write this out, it would be dot dot dot, n of them. So that is why a to the power of n divided by b to the power of n equals divided by b over n. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new. And I'll see you guys in the next one. Bye!